first thing we're going to talk about is actually the term client link. Many of you might not know that term. That term, it really is called beamforming nowadays. That's really what we call it. Used by APs with multiple in, multiple out antennas to improve signal to noise ratio. So what we're going to do is we're going to focus our beams to a particular point, and we're going to receive from a particular point. This is called beamforming, right? You learned a little bit about that in earlier lessons of this wireless course. Now, this can be changed by the CLI, the command line interface only, not anywhere else. And this is configured globally by radio type or by AP radio type. So we're really going to dive into the AP itself and find out what type of radio is this. The AP must support or must be capable of supporting ClientLink. We can't do this without the support from the AP itself. Doesn't matter what your wireless LAN controller could do, your AP has to support it. Not supported for all data rates. So we're not going to see all data rates supported here. 1, 2, 5, 11. A lot of these rates aren't going to be supported for our particular configuration. Okay, so 1, 2, 5.5, and 11 will not be supported as actual speeds when we're using ClientLink. All right, so let's jump out into my environment. We'll take a look at this actual Cisco controller. I'm going to go ahead and put in my username and then my password. This is going to allow me access. We now have access to the controller itself. We need to do a configuration, so I'm going to type in config here. Now we're in configuration mode. This allows us access. Now, if I take a look here at what's available to us, you can see we have a lot of the 802.11s. Now I have to focus on one of these. So let's say I don't really support this in my environment, but let's just call this 802.11a. All right, that's what we're going to configure. Now we need to actually look into beamforming itself. So if we see 802.11a, one of my options was beamforming. Now, if we look into the options there, we can see I can do this on a global basis for this wireless LAN controller, or I can do it for a specific AP. Let's choose AP in this case. AP, and let's see what else we have to put in. Now we have to put in the actual Cisco AP, the name of the AP. And then we could say, let's say this is Office AP. Okay, that was the name of it. I would hit enter, and then we could look at what's next. Can we disable, enable, or make it global? So let's go ahead and enable. We're going to make this enabled on ours. Is there any more that we could put in? No. Enable's good. We hit carriage return, and you can see I don't have an AP name that, but if I did in my environment, this would configure it. Okay, so this actual configuration changes. Some access points use it as an entire configuration, config 802.11a beamforming. So you, depending on your wireless LAN controller, your configuration may vary a little bit, but it'll look pretty much similar. So in my environment, it was the protocol we're using, 802.11a. Beamforming, again, that is what it's called. ClientLink capable means beamforming. And then our actual AP, our name of our AP, and then enable or global, whatever we used. And once again, remember the data rates, 1, 2, 5.5, and 11. The CCK data rates are not supported with beamforming. All right, moving on. All right, let's talk for a moment about band management or band select. Now, band select is a way for the wireless AP to control how our clients connect to us. Now, oftentimes we have the clients trying to connect in the 2.4 gigahertz range. If that can be avoided, we often want to avoid this at all costs because that range is much more crowded than the 5 gigahertz range. So enabled by default is band select. Band select is going to say, let's try and get everybody to join on the 5 gigahertz range. Only when we've exhausted this or when we're in trouble, let's use the 2.4 gigahertz range. Now, how does it do this? Well, first off, we can activate this by per wireless LAN. This requires that we're not using VoIP or any of that other stuff. VoIP requires that band select is not enabled. Okay, so we need to have full connectivity if we're going to use VoIP. Also, we have to have both antennas working for the access point. We have to have our 2.4 and our 5 up. That's the only way this is going to work. So let's dive into the actual configuration. Let's go to my environment and look at some of these different configurations we have here. First off, let's look at the probe cycle count. The probe cycle count is basically telling me how many times I'm going to ignore a request to join the AP at 2.4 gigahertz. I'm going to wait until the client attempts a 5 gigahertz connection. I'm going to ignore twice. If I say the probe cycle count, that's how long I'm going to wait. Now, the scan cycle period is how long that probe cycle is. So I'm going to wait 200 millisecond cycles. Okay. So I'm setting the length of the scan cycle period. Now, the age out suppression, this is how long I'm going to wait in seconds for a client to come back. Okay. So a client is on my channel. I'm going to wait 20 seconds for that client to scan all the other channels before coming back before I drop it. Now, age out on dual band. How long am I going to wait before I implement dual band connectivity, 5 gigahertz and 2.4 gigahertz? Next up, acceptable client RSSI. So, how much power is coming through the signal, or how far away or how much interference is between me and the client? If it's negative 80 dBm, remember that reference of dBm, the power of the signal strength is low due to distance or interference. I will not use band select at that point if it's at negative 80 or better. Acceptable client mid-range, so that would be negative 60. So you can see the different values here. If we go up to our slide, that's not the only values we can set for band select. We can also look at the load balancing aspect of it, client load balancing, client band select. That's what we're really looking for on a wireless LAN configuration. So when we go to wireless LANs, I click on number 1. What are we looking for here? We're looking for in our advanced setting, we're looking for load balancing and what? Load balancing and band select right here. You can see band select, like we said, enabled by default. Once again, the whole purpose of it is to move those clients that are trying to connect over 2.4 and bring them into the 5 gigahertz range.